Hello, Astronomy. Mr. Janowski here. This is part 3 of the chapter 3 slides. So, the do now questions. What was Isaac Newton's famous book explaining the laws of motion and gravity? That was the Principia, published in 1687, one of the most important books not only in the history of science, but really in the history of the world. It's actually that important. Principia kicks off scientific revolution, leading to industrial revolution, leading to the modern world. Um, Hugely important and influential ideas in this book. So, second question, what thought experiment did Newton use to explain how gravity kept things in orbit? This was Newton's cannon, and he had an image of this in the Principia. So remember, we talked about this in class last time. You imagine the cannon launching the cannonball horizontally at a great speed. It'll go for a while and then fall back to Earth. Well, if you launch it faster sideways, it will go further before it comes back to Earth, and the curvature of the Earth is going to start to matter. Um, and if you launch it really, really fast, the cannonball will just go sideways, and it will always be falling towards the Earth, but the Earth will always be curving away from it at the same rate at which it is falling. And so the ball will never actually get any closer to the Earth. It'll just keep going around and around. So this is how Newton visualized orbit, and this is what orbit actually is. So yeah, Newton's cannon. This experiment, by the way, you can't actually do it. There is air resistance that would ruin it. Also, you just can't launch a cannonball that fast. Everything would explode before you got it going that fast. But aside from that, it's a thought experiment. What Einstein would call a Gedanken, but that's besides the point. Third question, what is Newton's second law of motion? F equals ma. This is one of my favorite things in the universe. F equals ma. Force is equal to mass times acceleration. So F equals ma, that also means that a is equal to F over m because algebra. So that means if Leo Messi kicks a soccer ball and a bowling ball with the same amount of force, but the bowling ball, of course, has more mass, the bowling ball is not going to accelerate as much. And if you know Newton's second law and you know the masses and the forces, you can calculate the acceleration. So that was the second law. In the class before that, we covered the first law. Today, we cover Newton's third law of motion. So Newton's third law of motion, this is most commonly stated as for every action, there is an equal and opposite reaction. That's the way everyone knows it, just through like regular, parlance, in the parlance of our times, to borrow something from the Big Lebowski. Anyhow, yeah, that's kind of true, but it's a little misleading. That implies karma. That implies that if something happens in the universe is going to even it out somehow, and it's going to even up the score. And that is not at all what the third law is really about. So the third law is better stated from a physics point of view by what's in bold here. When two objects interact, they create equal and opposite forces on each other. So if the first thing puts a force on the second thing will put just as much force back on the first thing in the exact opposite direction. That is Newton's third law. So in these pictures, we have Alice and Billy, both of which have a mass of 50 kilograms. And in the top picture here, Alice is pushing on Billy. She's pushing her hand on his arm, and she's putting a force of 200 newtons. So we would write F of A on B, the force of Alice's hand on Billy's arm, is 200 newtons to the right. So we would call that, positive 200 newtons. Newton's third law says that if Alice's hand is pushing on Billy's arm, then Billy's arm is also pushing on Alice's hand with the same amount of force, but in the opposite direction. So you can say F of B on A is equal to minus 200 newtons, the minus meaning to the left in this case. So taking that Newton's third law of motion idea, and combining it with Newton's second law, well, F equals ma, so A equals F over m, we can now calculate the accelerations. So the acceleration of Billy, well, that will be the force of Alice on Billy divided by the mass of Billy, 200 newtons, so positive 200 newtons to the right, divided by 50 kilograms. Billy's acceleration would be 4 meters per second squared. If we do the same thing for Alice, A sub A, the acceleration of Alice, is equal to the force of Billy on Alice divided by the mass of Alice. So minus 200 newtons, meaning 200 newtons to the left, divided by 50 kilograms gives us negative 4 meters per second squared. So in this case, two skateboarders, equal mass. If one pushes on the other, well, the other must push back on the first one with just as much force. And because their masses are equal, their accelerations will be equal and opposite in this case. So now what happens if Alice pushes on Charlie? Charlie is a bigger kid. He's got more mass. Alice is still 50 kilograms. Charlie is 100 kilograms. So the third law says if Alice pushes to the right, 200 newtons, on Charlie, well, then Charlie is automatically pushing back with 200 newtons to the left. So we write that as negative 200 newtons. But their accelerations will be different. So the third law says the forces must be equal and opposite. If you use the second law and solve for the math in this case, you're not going to get the same acceleration. Last problem we did, we had equal and opposite accelerations. In this problem, you don't, because they have different masses. So when you do the math, Charlie's acceleration, a sub c, ends up being 2 meters per second squared to the right, whereas Alice's is still going to be negative 4 meters per second squared, which is to say 4 meters per second squared to the left. So that's how that works out. Another way to indicate this is if you imagine, you're standing in the middle of the road and a large land mammal, an elephant or a rhinoceros or something, comes charging at you and hits you. Which force is greater? The force of the elephant on you or the force of you on the elephant? Everyone likes to say that, oh, well, the elephant must be putting more force, because afterwards you look at how the motions change. Your motion will change very dramatically. You're going to go flying in the opposite direction. Whereas the elephant's motion isn't going to seem to change at all. So people think the elephant's putting more force on you than you're putting on the elephant. But Newton's third law says, no, the forces have to be equal and opposite in direction. It's when you bring the second law in that you find out the accelerations would be very different. The elephant having more mass than you means the elephant is not going to accelerate as much. The elephant will accelerate, just not as much. So Newton's third law applied to other things. Newton's third law of motion is illustrated by the recoil of a gun. So here's a rifle. There's a bullet in the chamber. You fire it. A chemical reaction goes off in the back. There's an explosion, and it pushes the bullet to the left. Okay. Well, that means whatever amount of force went on the bullet going to the left, you've got to have the same amount of force going on the rifle to the right. So that's what recoil is. Now, of course, bullets having very small masses, that amount of force is going to accelerate the bullet a lot, and the bullet's going to go flying out very quickly to the left, whereas the gun, with its bigger mass, is not going to accelerate as much. Again, the forces will be equal and opposite. The accelerations won't be in this case because they have very different masses. So this is also how a rocket works. So rockets are different than planes. Planes, whether they have a propeller or a jet, are essentially kind of swimming through the air. They're pulling on the air and they're swimming through in the same way that you could swim through water. Rockets are different. Rockets, can fly through deep space where there is no air to swim through. So how does a rocket work? It's going to blow something up. This is using a chemical kind of fuel. It's blowing something up and it's throwing the exhaust to the left behind it. So by throwing the exhaust to the left and putting a force on the exhaust to get it going that way, the exhaust also puts a force on the rocket to the right. So that is what makes the rocket go. So the rocket is basically throwing its exhaust to the left, and by doing that, it itself is going to the right. So you could imagine standing on a skateboard and holding a bowling ball. Well, if you toss the bowling ball one way, if you toss the bowling ball to your right, the bowling ball will go to the right. And you can imagine doing this. Don't do this at home, by the way. As you throw the bowling ball to the right, you're going to go to the left. That's how a rocket works. So, not very many slides today. Then we did the Kahoot, and there was a quiz on Google Classroom to do for homework. So hopefully you did the quiz, and hopefully you found this helpful.